Okay, let's look at something that can become useful down the road. If you're watching this from my class, you know that a TI Inspire calculator would allow you to input something like log base 7 of 4. Okay, like you can type this into your calculator and get a decimal approximation for that, right? Um, so the change of base formula for people my age and older was the only way to calculate logarithms like this back in the day. And you'll see what I mean here in a second. And rather than just giving it to you, I think it's important to understand why this works, right? So let's start by looking at just a basic logarithm like this. We're calling this log base x of y, and that's equal to z. And at this point, you should know that a logarithm is an exponent. So it has an equivalent form that we call exponential form, where we say the base of the log is the base of the exponent. So we have an x that is raised to a power. So this logarithm represents the exponent that I raised this to get this number, right? So in other words, because this logarithm is equal to z, z represents the exponent that I raised this number to get that, right? And so that's our basic uh, explanation for how to convert from what we call logarithmic form to exponential form. So now let's take a look at this exponential equation. Um, One of the properties of logarithms and a property of equality is that if I take a logarithm of one side, I have to do that to the other because a logarithm is an operation in itself as well. So uh, I'm going to bring in uh, log base, let's say a, okay, and then I would want to also do the same over here. I want to take log base a of this side, right? So my new expression or my new equation would say log base a of x to the z is equal to log base a, oops, that's an a, of y. Okay, so when you look at this, the equation still balanced. We'll get that eventually, right? The equation here is still balanced, okay? And we have a logarithm on the left side where we have a power inside of it. One of the properties of logarithms says that when you take the logarithm, when you log a power such as this that has an exponent, we can take that exponent and drop it down in front. So we took the log of both sides just as a way to re-represent an equivalent form of this expression or equation. So I have log base a on both sides. This logarithm has a power inside. I'm going to drop that power down in front. So that's z times log base a of x, which is equal to log base a of y, right? Now, if we're doing a proof here to prove why something works. So when you look at this, a logarithm is an exponent. It represents a number, right? So even though there are essentially 5 characters involved here, right? LOGAX. This entire logarithmic package represents a singular value. Okay. So what that means is I can, if this was a 4, right, I could divide both sides of this equation by 4. So we have to train ourselves to view this entire logarithmic package as one value. And if it does represent one value, then I can divide by it, right? I can divide this entire product by log base a of x. And in order to maintain the balance, I would do the same thing over here. So the statement that we end up with says z is equal to log base a of y over the log base a of x. And if you go all the way back to the beginning, we had a statement from the beginning that said z is equal to this, right? And this z, it's the same z as it was throughout this entire problem. So I rewrote this in exponential form and I did a little uh, property of equality to bring in this logarithm. Long story short, I ended up with this statement. So if z was equal to that original logarithm, and it's also equal to this by the transitive property, if this is equal to z and this is equal to z, then those two expressions are equal to each other. So log base x of y is equivalent to this other logarithm that has the same base. Okay, that's an x, sorry, here and here. And so the change of base formula, what it says is, sorry, let me get this out of the way. What the change of base formula says is that you can take any logarithm, okay, with any base, and you can represent that logarithm as a quotient of logarithms with a different base, right? And so what I was telling you from the beginning is that, back in my day when I was dealing with the TI 83 calculator, and I had an equation that looked, or excuse me, I had a logarithmic expression that looked like this. My calculator did not allow me to input the base of a logarithm. So I had to know that in taking a logarithm like this that I wanted to find the value of, I had to re-represent this logarithm as a quotient of logs. And it can be any base. Remember, this a that I chose here, that's just some arbitrary number. It's a variable that can represent anything, right? So I can write 10, I can write e, I can write 3. This number can be whatever I want. The calculators back in my day only knew common log and natural log. So I would have to take something like this, and I would have to say, well, log base 4 of 7 is equivalent to the common log of 7 divided by the common log of 4. This is the only way I could do that, uh, find the value of that logarithm, right? So, long story short, any log can be written as a ratio or a quotient of two logarithms where we make this the same base. So what you get in the habit of doing is taking something like this and saying, our two most basic logs are common log and natural log. So we can represent any logarithm we want as a ratio of common logs or as a ratio of natural logs. Notice I'm not writing the base here, but that's base 10, right? Okay, and so there's your change of base formula. Take a logarithm, any logarithm of any base with anything that's on the inside, and represent it as a ratio of common logs, where we take whatever's inside here that goes on top, and whatever the base is. I always think the base of this log becomes the basement of this ratio. So that's the way I've always represented it. This is physically written above this, so I write it above this when I represent that ratio. Okay, so change of base formula. Take any log, write it as a ratio of either common logs or natural logs. Mic drop.